In this video, you will specifically graph exponential and logarithmic functions in the standard viewing window. So before we begin, let's make sure that the calculator is set so that all functions will be shown in the standard window. So we go to the zoom button, select it, and then line number 6 here says Z standard, and that's the selection that we want so that the calculator will be in the standard window when we go ahead and view the functions. So we can either hit number 6, that's the easiest way to enter it, or you can move the cursor down all the way to this line and then select enter. So let's just hit number 6, that's the easiest way to get to the standard viewing window, and here it is shown. And as I mentioned before, the standard viewing window goes from -10 to 10 on the x-axis and -10 to 10 on the y-axis. Okay, so let's go to example number 1, and we are going to input the first function, which says y is equal to 2 raised to the x plus 1 power. So we need to go to the y equal button, that's the input function button, and let's go ahead and write in the equation. So that's 2 raised to the x plus 1 power. So you need to put the x plus 1 in parentheses, so x plus 1, and then close the grouping symbol here. Now, the reason why you need to put the x plus 1 in parentheses is because of order of operations, and if you did not put parentheses around here, the calculator would interpret it as 2 raised to the x and then add 1 to that. So you can see how the calculator would interpret this just to the right of your screen. So it's very important that you put grouping symbols around the exponent. Alright, so we're ready to graph this, so we go ahead and select graph, and there's our function. Okay? So let's go to example number 2. So remember, to clear this function, we go back to the input function screen, and we go ahead and hit clear. Okay? So on our next example, we're going to graph y equals the ln of x plus 2, subtract 4. So that is the ln of x plus 2, and then notice that when I hit the ln key, it automatically put a left-hand parenthesis here. Okay, so you just need to close the expression inside the ln. So I'm going to close it. So it was the ln of x plus 2 and then subtract 4. And we're ready to go ahead and graph this. So we hit the graph button, and there it is. So let's go to example number 3. But first we will go to the y equals button and select that. And then that takes us into the screen where you input the functions, and now we will clear the function. And now let's go ahead and graph y equals 1/6 of e to the 3x. So that's going to be 1/6 of e to the 3x, so it's probably easy to go ahead and go e raised to the 3x. Notice that it put a left-hand parenthesis in front of the exponent, so we need to close the exponent with a right-hand parenthesis. And we're going to divide that by 6. Another way you could input this, and I'll just show you on the next line, you could actually say in parentheses, you could put down 1 divided by 6 and multiply that by e to the 3x. So let's go second function e, and that's raised to the 3x. So here's actually two different ways you can input the same function. Okay, here it's e to the 3x divided by 6, which is the same thing as saying 1/6 multiplied by e to the 3x. So either one will work. I can actually show you that they are the same. Remember how we go ahead and turn off one of these functions? So let's turn this one off so it won't graph. And we do that by moving the cursor to the left. We want to get to the equal sign. And there the cursor is flashing, you can see on the equal sign. And if we hit enter, let me move down one, you can see that the highlighted part of the equal sign is gone. That means it won't be graphed. So if I go ahead and hit graph, the only thing that's going to show is this function here, because this is highlighted. Alright, so let's hit graph. And that's what the function looks like. So if we go back into the place where we inputted both the functions, if I turn this function back on, so we move the cursor to the left and then we go ahead and hit enter, let's move down one, we can see that both of the equal signs are highlighted. So what it's going to do, it's going to graph this function, and then it's going to graph the same function here. Now, indeed, if they are the same, then you should only see one curve. So there it is. It's the same curve. So that just shows you that both of them are the same. They're equivalent. Okay? Before we move on, there is something very important that I would like to mention about this graph, and that is it's very deceiving. The domain for y equals 1/6 e to the 3x is all real numbers. So the graph exists to the left of the y-axis as well, even though it doesn't show it. So right here it doesn't look like there's any part of the curve, where in reality this curve does go along the x-axis. The y values are very small, so the graph appears to cling to the x-axis when x is less than 0. This would be shown by turning off the axes. So we can turn off the x-axis and the y-axis, and then you'll be able to see the graph without any of the axes. So how we do that is we go to second function and then hit this button here, which is going to operate catalog. Now these are all in alphabetical order, so we can scroll down and we should soon see axes off. And there it is. So select enter, and then enter again. And now it says that it has been completed. And now we can go ahead and select graph. And here's the actual function without any axes showing. And you can see that it continues on. Alright? Before you could not see this because the y values were very small, so it appeared as if the curve was clinging to the x-axis. Now to turn back the axes on, we go second function, then select this button, and scroll down. And there it is, and we select enter, and then enter one more time, and then it says done, which means that it has been completed, and we can select graph again, and you can see the same curve. So I just wanted to bring this up. Before we move on to the next example, we need to clear out what we have inputted for y1 and y2. So hit y equals, then hit clear to clear the first one, then clear to clear the second one. Now we can move to example 4. Okay, so the next one we're going to graph is y equals 2 times the log of 7x. So that says 2 times the log. And notice here that it automatically put a grouping symbol on it. So of 7x. And we close that expression. And now we are ready to graph this. So let's go ahead and hit the graph key. And there it is. Okay, so let's go ahead and graph our last example, example number 5. So let's go back to the input function key. Let's clear this out by hitting clear. And what we're going to do here is we're going to graph y equals the log of base 5 of x. Now, one thing that I need to mention here, and that is this log key, all right, means the log of base 10, and only base 10. So I'm asking you to graph the log of base 5. So how do we do that?
Well, the TI-83 series calculators don't have a way to graph logarithms with bases other than 10 or e.
So what you need to do is you need to use the change of base formula. You'll learn that in your math class. But basically what the change of base formula is, it says to take the log of the expression, and in this case the expression is just x, so you take the log of x and then you divide it by the log of the base. And the base here happens to be 5. So your change of base formula will tell you that the log of base 5 of x is equivalent to the log of x divided by the log of 5. So what we're going to do is we're going to graph the log of x divided by the log of 5. And that's how you take care of graphing logarithmic functions that have a base other than
10 or e.
Now remember that the ln key, that actually is the log with base e. So that's already taken care of for you. If you have a base e for the log, that's the natural log. So we're ready to graph this, and let's hit graph. And that's what the function looks like.
For the TI-84 series calculators, the easiest way to graph a logarithm with a base other than 10 or e is to have your calculator in math print mode. Go to the mode key and select it, then scroll down, and you can see that the math print is highlighted. For the TI-84 Plus CE or the TI-84 Plus C, your screen will look a little bit different. Your math print in Classic will actually be at the top, and you will not need to scroll down. To get out of this screen, go second function quit. And now we would like to graph the function y equals log base 3 of 2x plus 1. Select y equals. Make sure that all of these plots are not highlighted, and they're not. And we'll go ahead and input the function. So we'll start out by selecting the alpha key and then the window key. And that pulls up this menu here. And you want to select number 5. And it's very simple to input the function now. So the base in this particular example is 3. Select 3, and then move inside the parentheses, and now enter in the expression, which is 2x plus 1. Then you want to move to the right to get out of the parentheses. So select the arrow key, and now you can see the function is inputted correctly. And then just simply select graph. And there's the function. Alright, if you want to keep your calculator in classic mode, this is how you would graph the function. So let's go back to y equals. Let's clear the function, select clear, and let's get out of this screen. Second function, and then quit. Now, we have to go back to the mode key, select that, and let's scroll down, and let's put the calculator in classic mode. Select enter, and then second function quit. Now let's graph the function again, except now we're in classic mode. Select y equals, then the same steps, select alpha and then the window key, and then select number 5 for log base. Now notice it's a little bit different. The first thing that you're going to do is you're going to enter in the expression, and that's 2x plus 1, and then separate that with a comma, and now enter in the base, which is 3. And then close the grouping symbol, and there's the correct format if you're in the classic mode. It's the expression, and then a comma, and then the base. Now you can select graph, and you can see that we get the exact same graph as we did before when we were in the math print mode. Again, this only works for TI-84 series calculators. As mentioned previously, if you have a TI-83 series calculator, you will need to use the change of base formula to input a function with a base other than 10 or e.
So this concludes the video on graphing exponential and logarithmic functions.